What are the main types of kinematic motion in physics? Have you ever wondered how objects move in our world? Kinematic motion in physics is all about that. It describes how things move without focusing on the forces behind the movement. Let's break down the main types of kinematic motion that are essential in both physics and mechanical engineering. First up is linear motion. This type of motion occurs along a straight line. It can be uniform, meaning the speed stays the same, or accelerated, where the speed changes. Key factors in linear motion include displacement, which is how far an object has moved, velocity, which is the speed and direction of that movement, and acceleration, which measures how quickly the speed changes. Understanding linear motion is vital for analyzing mechanisms like pistons and sliders in machines. Next, we have projectile motion. This type of motion happens when an object moves in a curved path, often shaped like a parabola, due to gravity. In projectile motion, the movement can be split into horizontal and vertical parts. The horizontal speed remains constant, while the vertical speed changes because of gravity's pull. This concept is important in fields like ballistics and robotics, especially when launching objects into the air. Then there is rotational motion. This involves an object spinning around a fixed point or axis. Instead of measuring distance in a straight line, we look at angular displacement, which tells us how far the object has turned. We also consider angular velocity, which is how fast it is spinning, and angular acceleration, which shows how quickly the spin speed changes. Rotational motion is crucial for understanding gears, turbines, and other rotating machinery. Another type is oscillatory motion. This is the back and forth movement around a central position, like a pendulum swinging or vibrations in machines. Oscillatory motion has specific characteristics, including amplitude, which is how far it moves from the center, frequency, which is how often it moves back and forth, and the period, which is the time it takes to complete one full cycle. This type of motion is essential for studying mechanical vibrations, which can affect the design and durability of structures. Finally, we have curvilinear motion. This refers to movement along a curved path that is not always parabolic. It can happen in a flat plane or in three-dimensional space and involves changing direction and speed. Curvilinear motion often requires vector analysis to understand velocity and acceleration. This type of motion is commonly seen in robotics and vehicle dynamics. In mechanical engineering, knowing these types of kinematic motion is key for designing and analyzing machines and systems. For instance, understanding rotational kinematics helps calculate how fast gears turn, while principles of projectile motion guide the planning of trajectories for robotic arms or drones. Each type of motion has its own set of variables and equations that describe how position, speed, and acceleration change over time. This knowledge forms the foundation for analyzing mechanical systems and their movements.